Hello everybody! If you want to know how to buy electronic components online with part number, stay here. I will show you 3 manufacturers of the best technology for SMD resistor as well as their part number. Tolerance. Tolerance is basically standard in the industry. J will be 5%, F 1%, and D 0.5%. You will find the information in the data sheet. There is one difference. For 1%, 0603, they use FX, resistance. R is very important, is decimal point, means decimal point. No mark on chip for size 01005, 0201, and 0402. 1 ohms in 5% reads 1 decimal point, R decimal point, 0 is the number of 0. So 5%, they use just 3 digits. This first 2 is the significant digit. The third one is the number of 0. 1%, 0.5%, they use 4 digits. The 3 first digits is the significant number. The fourth one is the number of 0. And mark on chip follow the part number. So 1 ohms will be 1 R decimal point 0. The number of 0 equals 0. Mark will be the same. 1%, 1 R decimal point 0, 0 the number of 0. 0.5% is the same, and the mark on chip will be the same. 10 ohms will be 1 0 and the number of 0 0, same as mark on chip. 1% 1 0 decimal point number of 0 0, same as 0.5%, same as mark on chip. 100 ohms 1 0 and number of 0 1, mark on chip, the same as the part number. 1% 1 0 0, number of 0 0, same as 0.5%, same mark on chip. 1k ohms, 1000 ohms will be in 5%, 1 0, number of 0 2, same mark on chip. 1% 1 0 0, number of 0 1, same 0.5, same mark on chip. 10k will be in 5%, 1 0, number of 0 3, mark on chip the same. 1% 1 0 0, number of 0 2. As you increase the value, just increase the number of 0 and it's easy to understand. You will find all this information in the data sheet. TCR. I made a table for TCR. Rohm does not have the TCR in the part number, but they have information about the TCR in the data sheet. TCR is temperature coefficient of resistance. Is how much the resistor will change with changes in the temperature. Is expressed in parts per million, per degree Celsius or Kelvin. In this case, 01005 will be minus 100 to plus 600 parts per million per degree Celsius or Kelvin. Doesn't matter, Kelvin or Celsius will be the same, just the reference is different. 01005 TCI will be minus 100 to plus 600 in 1 ohms to 10 ohms in 5%. 01005 will be plus or minus 300 parts per million per degree Celsius in 5% from 10 ohms to 100 ohms and 1% from 10 ohms to 100 ohms. As you increase the resistance, you see the TCR improve. 0201 minus 200 plus 600 from 1 ohms to 10 ohms. Lower resistance, the TCR is worse than when you increase the resistance. 0201, you already have 0.5% tolerance. You will find all this information in the datasheet. 0402 follows the same, the other one. 1 ohm to 10 ohms minus 250 to plus 500. And you increase the resistance. Now you have plus or minus 200 from 10 ohms to 10 megohms. You have here plus or minus 100 in 1% from 10 ohms to 2.2 megohms, and in 0.5% from 10 ohms to 100 ohms. And you have a wonderful thing here is plus or minus 50 from 100 ohms to 1 megohms in 0.5%. 0603 will be plus or minus 100 from 10 ohms to 10 megohms, and the part number, the tolerance in the part number will not be F, it will be Fx. 0805 also you have plus or minus 50 parts per million per degree Celsius. And 1206 you also have plus or minus 50 from 100 to 10 megohms in 0.5%, and 1 ohms to 10 ohms plus or minus 400 parts per million. 1210 you have 1 ohms to 2.2 ohms. The TCR is higher, plus 500 plus or minus 350. 1210 you have here plus or minus 200 from 5.6 ohms to 3.3 meg. In 1210 you have different TCR for different range of the resistance. Plus 500 to plus or minus 350 from 1 ohms to 2.2 ohms, and 2.2 ohms to 10 ohms plus or minus 500. 330 kilo ohms to 560 kilo ohms plus or minus 350. 2512 also you have 500 plus or minus 350 from 1 ohms to 2.2 ohms, 500 to 2.2 ohms to 10 ohms, 2512 plus or minus 500 from 2 ohms to 10 ohms. And also you don't have 0.5% in 2010, but you have here plus or minus 100 from 10 ohms to 82 kilo ohms, and the maximum here in 2010 is 180 kilo ohms. During the presentation I spoke about milliohms, kilo ohms, megohms, k ohms, gig ohms, and I didn't explain exactly what it is. This table is explained to you what it is. Kilo ohms is 1000 ohms, megohms is million ohms, and gig ohms is billion ohms. Thick film. Thick film use a substrate from aluminum oxide, which this manufacturer is Kyocera. I will put link down below. They manufacture aluminum oxide as a substrate for thick film, as you can see here, and thin film. You will notice that there is two different substrates, one for thick film, one for thin film. The reason why is, for thick film the purity is 96%. For thin film the purity is 99.6%. Well, why they use aluminum oxide as a substrate? Because it's recyclable. You can recycle several times. It's non-toxic, it's harder, it's abrasive, and the melting point is 2072 degrees Celsius. And also the thermal conductivity is very good. Metal glaze is glass powder and metal particles. The metal could be palladium, bismuth, all this, okay? And their oxides, of course. After the application of a metal glaze over the substrate, the material goes to a kiln. Nitrogen, instead a regular air, is the solution to avoid oxidation, and the temperature reaches between 800 degrees Celsius and 900 degrees Celsius. In the end, the parts are cut at the right size. A laser cuts the metal glaze to reach the correct resistance. The best description I found was in this website. I will put the link down below. They manufacture thick film products. They have a very good description, and in their description they mention silver palladium and gold palladium. Also the oxide, silver and ruthenium in different combinations. He described that the metal glaze can be applied in the form of ink as a screen printing process. After they trim it with laser to reach the right resistance, they apply a coating for protection, install the solder plate, and is ready for the customer. We have reached the end of the fourth lesson on how to buy electronic components online. We finished Vishay and now Rohm. You have enough information to know that there is a difference between resistors. Power dissipation at 70 degrees Celsius, maximum working voltage, and TCR change from one part number to another. How much can this influence a specific application? Only the engineer in charge can answer. If you like the video, consider subscribing, give it a like, and share. Also, if you have any question or suggestion, leave a comment below. I try to answer the best way possible. Thanks for watching the video. I will see you in the next video.